Okay, so here's our we do today for students that didn't make it today. So let me zoom in. This is basically about a subway train. Ember read it already. I'm just reading it again. So a subway train will, speeds up with an average acceleration of 3.57 meters per second squared. How much time does it take for the train speed to increase by 4.35 meters per second? So we're talking about an acceleration for one. If you can't figure it out, that's what those are. And then the other one is, of course, a velocity is meters per second. So they're asking about how much time, though. So this is a quick algebra problem, believe it or not, and we're going to go through it together. So if I turn this around, I don't think that's good because it's going to be inverted, isn't it? Yeah, I see it. I'm looking at that. That's what I saw when I reviewed this stuff. So we're going to do it that way, so it's not inverted in the students. The students like, it looks reversed. I was like, yeah. So let's angle this up. I think I cleaned the board. Yeah. So let's take care of this problem, all right? And then once you get that all typed up, Amber, you're gonna look up here and type up the rest of the notes to do the problem. The problem itself is specifically on page 78. So once you get done with 75, and you got your notes on what the problem is all about and what the equation is all about. The problem is right here. It's just they don't show you all the steps, and that's what I'm here for, to show you the steps in between that they don't show you. All right, because you can't get full credit if you don't know what happened. So when you're done, you gotta type everything I got because it shows all of the algebra steps. All right, now we just looked at the same equation for average acceleration within our do now section. So this is our we do segment. All right. We do it together. I do a simulation where I show you how to simulate it in real life. So again, you're still using an equation called average acceleration, right? And with that one, all you have to do is rewrite the equation, but there's a variation of the equation. So if you got 2 points for your velocity, initial and final, and 2 points for your time, initial and final, then you would write that. If you only have one, you would just probably put that value and call it TF or delta V or delta T. So here it is. It's the variation forms. So you have AV for average acceleration is equivalent to delta V over delta T. Another form of that is, you know, delta is displacement, so you can say that is VF minus VI divided by, well, displacement works on time or any variable there, so it's TF minus TI, okay? Let's flesh this out some more. Of course, when you type it, you're looking for the symbol. I'll show you how to do that once you get this math done. There's a way to put that delta symbol in there. You just go to your special character set, and you type PELTA. It'll give you a triangle that you can pop into your document. Anyway, what are these measured in usually, right? So we know our velocities are measured in terms of meters per second, right? Our times are measured in terms of seconds. And then you have this sucker right here, this joker right here is a derivative, a step up from the velocity. So this is measured uniquely in meters per second squared. All right. So now we got to work on our known and unknowns. What I mean by that is, what is the problem giving you, the ingredients to solve the problem, and what is the problem asking of you to solve, right? So what do we know? That's our tool. We're going to leave that up there. And then this is also being asked of you, what is unknown, or what is the question asking us? So to do that, let's pick this problem apart slowly, right? So if you're looking at the problem over there, it says the subway train speeds up at an average acceleration of 3.57 meters per second squared. That tells me automatically, if I look at how I labeled all this, that this is going to be, that's why I labeled these so you'll know, it's going to be your average acceleration. So I'm going to say AV is equivalent to 3.57 meters per second squared. What else does the problem give us? Well, let's take a look real quick. We know that it says how much time, I'll say it again, that's a question. So that it's got to be what they're asking you. In this case, you can just say, hey, I'm looking for delta t, because you don't have 2 time frames. So you can just say that, question mark, and seconds. Then we read the rest of the problem. It says, how much time does it take for the train to increase by 4.35 meters per second? Well, meters per second is a velocity. So since I don't have 2 of them, like a final and initial, I can just say, hey, delta v is that. And that was, what's that number again? It was 4.35 meters per second. Okay? So far, so good. Now, if you had, say, you wanted to use this equation up here, you would say the initial is at rest. So another way to write that is, I don't want to confuse you, I'm gonna write it so you'll know, but I'm just doing this because it's simple. But if you have a situation where you have 2 velocities and 2 times, you would use this one. So another way to write that is, say VF was equal to 4.35. You don't have to write this part. Remember, I'm just showing you so you'll know. And then VI, if you want to write it that way, you have to assume it's at rest because they didn't give you a starting velocity. So you can just write 0 meters per second if you want to use this equation. Same can be done for time, but we're starting for time here. I'm just showing you how it works. So if you had time, you can say whatever time was final and its initial is 0. Right, so let me erase that. I just want to see, I just want to show you the variation. We're going to use this to keep it simple though. So the equation we're using is, do this. There's not a lot to this problem. It's a lot of steps though, but not a lot. So now what do? Well, we're solving for, right? This is a step A, if you will. What do we say? Delta t, right? Using our algebra skills. And we just take this equation, and I told you, right, AAV equals this or AAV equals that. We're going to use this one to keep it simple and sweet. So AAV is equal to delta V over delta T. And then what we do is we're going to write it one more time and do some surgery on it and get delta T by itself. So let's go ahead and do that. So AAV is equal to delta V over T. Delta T. And where's my other marker at? Let's use blue. So again, this is being divided. We saw this earlier and do now. We got to bring it out the denominator. So this is being divided. We're going to multiply it. And that's the opposite of division. Okay? And once you do to one side, you got to do to the other. So come on over here to the other side of the equal sign. Okay? We can cross these two out because delta t divided by delta t is 1. Rewrite the equation without, things crossed out. And this just comes down, so you have delta t times A B is equal to delta V. Okay? You come over here, finish off because I'm running out of room. So there's a few steps. So you see we're real close to delta t. I'm going to write it again and we're going to do some surgery on it. So we're going to say, hey, what is it? Delta t times average acceleration is equal to delta v. And what I want to do is I want to get delta t by itself. So I see this multiplication right here. I need to do the reverse multiplication here, right? So we do division so I can get AAV over here and delta t all by itself. So I'm going to say, hey, AAV, right? What you do one side, you have to do the other. Stay consistent. I can cross out my average accelerations and rewrite my equation, then plug in my numbers, and I'm done. And this is the part everybody loves, when you put the numbers back into the letters so you don't look confused. I don't know why letters scare people, but hey, that's the way the mathematics is. So it's delta t is equal to delta v, just rewriting it so it's clean, over your average acceleration now from the algebra we did. This is AAV, by the way. I'm writing fast. Okay, AAV. Now, like I said, we're in a home stretch. We can go ahead and put our numbers in. So I'm going to conclude. Let's just bring this up one over here. So I can have it up, not down. You can see everything. So we end up with what? Well, that's going to be delta t. And at this point, you just start using your ingredients. So we know what? That delta V was 4.35 meters per second. We know what our average acceleration was is this. So that's 3.57 meters per second squared. Come down one, delta T is what? Now keep in mind some things will cancel out, so you leave only seconds. Meters over meters will cancel, so they'll go away. And this second square will come upstairs while this one will go downstairs, leaving only seconds. Okay, just something to keep in mind. So we grab our calculator, so I put calculators everywhere for everybody. We type in what we have. So that'll be, hit the fraction button, and you got 4.35, right? There's down key 3.57, and you end up with a new time of 1.22 seconds. So final time is 1.22 seconds. And that was the end of your we do. So try to finish up what you can. You say you got good internet at home. Try to turn it in by just emailing it back to me, and I'll grade it and see what you got. Try the you do problems too. I think you can do it. It's the same problem, just different numbers. You got your exit slip info, and you only got 8 more minutes of class left. All right, so I'll post a picture in here. Do you need me to send you a picture of this in the email maybe, or would that help? Yeah, kind of, okay. I know it seems like a lot, but once you get the hang of typing it and stuff, it go real smooth. All right, now, I forgot to stop this. Make sure everybody saw that. Oh, hey, Genesis, another student, former student. Yeah, so that's all the steps, y'all. I'm gonna try to post this video later for students that missed class today. All right, that's it.